difference of across the group. So we are trying to testing the difference in the regression function across the groups. So we want to see the this is a cumulative GPA. Right? Is it female or one male? So we want to see the gender difference, and then this is a SAT score, and then female and SAT score. So you can see the SAT effect will be different with the female and male or the same. And this is high school rank percentile and so on, right? And we want to see the interaction together. And restriction model is we taking out all the female related terms. So this is female related terms, female related terms, and female related terms, and female related terms. Only leftover is a SAT, high school rank, and then also I don't know what it is, total hours spent. Right? This is a restricted model, so you can tell all our null hypothesis will be this is 0, right? And this is 0, and this is 0. This is 0. Then we can test using, remember the unrestricted model and restricted model, and then we can do the F test. You can find out. You can find out is it there is a female effect or not. Not only the pure female effect, and including the SAT and high school percentile or the total hour altogether. Is there any effect on the female or not? Then you can do the t-test. Okay, so again, the null hypothesis is all of them are 0. Right? Any female related coefficient, and then estimate of the unrestricted model. So if you can test, so if you take a look at it, if you do the regression at all here, the tested individually, which is the t-test, all of them are not significant. So we cannot reject the null hypothesis. So null hypothesis is so individual null hypothesis. We cannot reject this one. We cannot reject this one either. All of them, we cannot reject all of them. However, we want to know is there the significant difference between female and male, and we take it out to the all female related part. That's why we created a restrict model in the previous slide, right? And then we do the F test, and we can tell is there is any female effect or not. And you calculated the F test. Yeah, again, we don't calculate this as by hand. Yeah, and null hypothesis rejected, which means we cannot tell altogether jointly female has an effect, which means there is a difference between man and woman. Okay. Yeah, so the another way is you have to calculate the SSR and SSR with the unrestricted model and restricted model. However, you better, if you have to do this one, you better use the what we use in the R, the hypothesis function, with the cat package. Right, in R we have the cat package, and then I think it was like a hypothesis function, then you can get a F test. Linear probability model. When this binary value, so this chapter is about the categorical variable, so binary variable. But this binary variable is independent variable, not dependent variable. What if y is 0 or 1? This model we call is a linear probability model because your y is a 0 or 1. So we are estimating y that will be between 0 and 1. So it's like a probability of being 1. So our estimation will be not exactly 0 or 1, but all outcome is 0 or 1. However, our estimation will be like a 0.7 or 0.3. So we interpret that decimal number is the probability of being y equals 1. Okay, when the dependent variable is binary. So we will do the same regression model, but now y is the binary variable. So if you take a expectation on both sides under the given x information, and then this one change to the this, so you can interpret the result of the y hat will be the probability of y equals 1. So I will not just dig into the here because this is quite a lot of problem here, and then that's why the people created another regression. So we will use a logistic regression, which we will take over in the second part of this class. So labor force in labor force is 0. If it's not in the labor force, this will be no, in labor force is 1 and not in the labor force is 0. So this one is 0 or 1. But actually, if you just plug in all the number here and calculate, this number will be a certain supposed to be 0 or 1, but actually you will get like a 0.7 or like a 0.38, something like this. So how can I interpret this one? This is the probability to get into the labor force. Okay, this is the same way you can what the regression is exactly the same. Female labor participation, the married woman, you can find out the problem of this is that this is linear because of what we talk about is a linear and then linear regression here. So problem is you can have some negative things. If you find out some case is here, your estimation can be a negative probability, but actually negative probability is not exist at all. And the maximum is not 1, so it's supposed to be 1. But you cannot reach 1 and then it goes down to the negative number. So that's why this is not that great model. That's why we will use a logistic regression later when your dependent variable is 0 or 1. Okay, so you can just think of it as a linear probability model is using the linear regression. We can still do the regression and find the probability using linear model. However, again, when our dependent variable is 0 or 1, so we will not use a linear probability model. We will use a logistic regression. Sometimes it goes larger than 1 or the smaller than 0. That doesn't mean anything. Some marginal probability effect is sometimes logically impossible, right? So that's why there is a lot of different things. However, what is the advantage of the linear probability model is the easy estimation. You can tell easily what is going on, right? So interpretation is easy. You will see later the logistic regression is really more complicated to interpret. For some model this works pretty well, but but like a rule of thumb is when your dependent variable is 0 or 1, we use a logistic regression. So that's why I'm not emphasizing the linear probability model here. Policy analysis, same as like a program evaluation. When we do something, I want to know what is the effect. So this is like a job training grant again. This is a firm's scrap rate, and then this is the job training grant. This is again the binary variable. If it's 1 if the firm received the training grant, and 0 otherwise. So we want to find out this grant, what is the effect on the firm's scrap rate. So if the firm get a training grant, they do the training and then they reduce the scrap or not. So we can find this negative number. So when you give a grant to the firm will do the training, and then as a result the firm will have a smaller scrap rate, right? However, if you run this one, then this is no apparent effect on the grant on the productivity. Probably you cannot reject it as 0. So we can divide the two groups: it's a treatment group and the control group. Treatment group is the grant, the company who received the grant, and the control group is the company that didn't receive the grant. Yeah. So actually there's a problem. It's a grant or given on the first come first serve base, right? This is not randomly distributed. So maybe the firm with the less productive workers saw an opportunity to improve the productivity and apply the first. So most of the firm who get a grant is usually has a low productivity. So even though they improved, the most of the other company who didn't get a grant is already good productivity. So if you compare the productivity, maybe these two companies are pretty similar, because the company who got a grant was pretty bad, but now is getting better, and all the company who didn't get a grant is already good. So both of them are similar. Then you can say, yeah, there's no effect on the grant, right? So actually, to see the effect of grant using the regression, you're the grant the distribution of the grant, the company who got a grant is the randomly distributed over a lot of different productivity level. So some good productivity company also have to get a grant, bad productivity company also have to grant, and then this grant should be distributed pretty evenly, randomly assigned. But usually when we do this policy analysis or the program evaluation, we just collect the data. We cannot control who will get the grant. So since if you know, I want to know what is the effect of the grant, and then you can just randomly select the company and then give a grant. That's not how the real world works, right? So usually afterward, after the providing grant is done, and you just collect the data afterward. So basically there's a lot of the problem when you collect the information or collected the data. Maybe the program is not evenly distributed over the different productivity level.